Alright, this is my video reassessment for forces. We will do number 64, page 116 on Cutnell and Johnson. It's pretty similar to the quiz. I'm going to read the problem right now. A block is pressed against the vertical wall by a force P, as the drawing shows. This force can either push the block upward at a constant velocity or allow it to slide downward at a constant velocity. The magnitude of the force is different in the two cases, while the directional angle theta is the same. Kinetic friction exists between the block and the wall, and the coefficient of kinetic friction is 0.250. The weight of the block is 39.0 newtons, and the direction angle for the force P is theta equals 30 degrees. Determine the magnitude of P when the block slides up the wall and down the wall. Okay, first we start by making a free body diagram. There's four forces acting upon the object. The normal force, which is perpendicular to the surface, the weight, the force of the push, and then the friction. Theta equals 30 degrees. And then go over here. Sum of all forces equals 0 because the velocity is constant when we're going up or down. Sum of the f of x equals p sine theta. Opposite. Minus n. Sum of the force of the y equals p cosine theta, adjacent, plus friction minus mg. Okay, then we get this. Friction equals mu times normal force. And we plug that into this over here. Then we get mg equals p cosine theta plus mu k n. We use our algebra. We get mu k n equals mg minus p cosine theta. Then you get n equals mg minus p cosine theta over mu k. Then we plug that in to our first formula over here. And you get 0 equals p sine theta minus what used to be n. Then you get mu k p sine theta equals mg minus p cosine theta. Then you get mu k p sine theta plus p cosine theta equals mg. Then you factor that out, and you get p, and you get your separate from your equation over here, because they both contain p, equals mg. And you divide mg by this, and you get that. So, for the p has to be 39.35 newtons, and for it to go up, p has to be greater than 35.35 newtons to go up, and p has to be less than 39.35 newtons to go down.